Just really quickly, I want to let you know, I don't know if you remember the problem that we tried to record yesterday and then OneNote decided it wanted to eat the problem. I tried to open it again last night. It was like, no. Anyway, I did the problem today during third period, recorded it, and it is up on YouTube. So if you want to go through that, you are absolutely welcome to. The answer is 3/4. I should have just told you that yesterday and I totally forgot, but it's 3/4 of H. I'm not going to go through it because I don't trust OneNote and I think it will just decide to eat it again. So anyway, the video is up there. It just says chapter 10 question, whatever it was. So you can go through that, watch it as many times as you want, and then you'll know what it is. So anyway, that is there. We're going to do some ranking tests today, and I'm going to introduce the lab to you that we will do tomorrow, but you're going to do some of the processing for it today, I think. We'll see how this goes. All right. So, oops, there it was. Ha-ha. Okay. So this is the one that we ended with yesterday, but I don't think we actually discussed yesterday. Is that correct? Like it decided that it was time to be done with the day. And I don't think I actually had answers written down. So instead of just trying to teach you this one right now, I want to give you just a minute to look at it again. So again, remembering that we have archers that are standing on top of tall buildings. I don't know, it's kind of a mashup of fun here, okay? They're either shooting their arrows at 45 degrees up, 45 degrees down, or straight, okay? It says to rank the speed of the arrows just before they hit the ground. So I'm going to give you just a minute, since you've had 24 hours to kind of flush your brain of this stuff. A couple minutes here to talk to your table mates, to come up with an answer. I'm going to get you some boards if you don't have them, so that you can come up with an answer, all right? All right. So give me some answers, my friends. What do we got? I'm going to move this and make it a little bit littler, maybe. Okay. So we've got CEA. CEABD, 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 CABD, C. Oh, look at you all! Now, would it be really bad if you're all wrong? Yeah. That happened one time. It was like, I don't know, 10 years ago or something. And I was teaching APC, I think, and yeah, I don't know. It was sad. But anyway, we learned from it. It was great. So let's make sure that didn't happen now, because I don't know what the answer is. Somebody defend that answer for me. Go.
It's dependent on the height and not the angle. So you just rank it from greatest height to lowest.
Yeah. Yeah. Total energy. We've got kinetic and we've got potential up here, right? And the potential is dependent on the height. And the kinetic is all the same because it's all 1/2 mv squared. Down here we've got all kinetic. So it's, yeah. Good for you guys. High fives. All right. More?
Yes.
More, please. All right. This one's not a ranking one. It's a question. Right? This is fun. For extra excitement, there's a new roller coaster ride that's designed to launch riders over an alligator-infested lagoon. The frictionless coaster starts at rest at point. Doesn't that sound great? Yeah. The coaster lands on the ramp on the other side of the lagoon. After it is airborne, will the maximum height of the coaster be greater than, less than, or equal to the height at point A, so that dotted line? So why don't you think, what's that?
Welcome to the frictionless alligator ride.
I think you'd have to work on a little bit better name than that. I don't know. That's a little on the nose for I think what we're doing. All right. Do you want a second to think by yourself first?
Yeah.
Yeah, okay, I'll give you like 45 seconds by yourself and no talking. You think in your brain. I feel as though we have either A, digressed, or B, are just ready to move on. So let me see your answers. All right. Wait. Y'all are saying 3 equal to or something else that's forfeited. All right. Get it? Forfeited? That was not intentional, but it worked out well. All right, here we go. Defend your answer. Go, Henry.
There's no friction.
That is true. There is no friction. That doesn't answer my question for me, though. Draw for me the trajectory of this cart. What's it going to do? It's going to go up. And you say it's going to go all the way up there? And then come back down, something like that?
Yeah.
Yeah? It's like a cosine curve? Yay? Now, I'm just kind of supposing. Now, the pink stuff, this thing looks a whole lot like a what? A parabola. What kind of motion? Parabolic motion or projectile motion? That's what I was thinking, yeah. I have a question for you. The velocity goes like this, and then the velocity goes like this, and right at the top, what's the velocity?
Zero.
It's going forward.
What's that?
It's still moving forward.
It's still moving forward. So what kind of energy does that have up here? Well, it has some potential, right, relative to this spot. It also has some what? Kinetic. Abhishek, you just made a face. What was that face about? Or was that just like a thinking face? Oh, it wasn't like an aha face? I have a question first. Can I ask my question first? Is that okay? Really quick. All right, what kind of energy do we have here, friends? All potential, right? Here we've got all gravitational potential. What about right here? That's all kinetic, baby. That's right. Now, as this thing is traveling, when it gets here, it's got some kinetic energy. You with me there?
Yeah.
If it's got some kinetic energy, what? What has to happen? Can it go up that high?
No.
No. Why not?
Maybe it can.
Go, Gunnar. You look like you want to talk.
I just have a question, because what if it just goes straight up?
But it's not going to because it's going up at an angle like this, right? If it goes straight up, then bad. We got to look at the picture. Okay, but here, shh. I think you guys are missing the crux of what I'm trying to get at. If at that point way up there, I zoomed it in so you can't really see it, but way up there you've got only potential. That means anytime that you're at this line, you have to be only potential.
Well, that's crazy.
But
Maybe this is an exception.
But
is it possible for that to be an exception? Go ahead.
I thought that you couldn't, because if you have only potential here, and then you have some, but wouldn't you still have this? Oh, I guess you wouldn't have the same potential. I was thinking, because then wouldn't it, on that graph, wouldn't it go above the ET line then?
Right. That's my point.
Yeah.
So did you guys hear what Courtney just said? Do you want to say it again, or do you want me to try and
I can try.
go for it?
So at point A, it has all potential energy.
Mm-hmm.
At the top, right there, at C, it has potential and kinetic, but if it has the same amount of kinetic potential that it had plus kinetic, then it goes above the ET line at the top, that dashed line.
It's not gonna go above the total.
It can't.
That's the point.
So, what does that tell us, friends?
It has to be less than.
Has to be a little bit less than, doesn't it?
They died.
Rest in peace, cosine.
It can't be equal to. Courtney just said it can't be.
I was right.
And she uses physics. It's a beautiful thing. You have to have potential and kinetic here. And if you have potential and kinetic and it has to equal this amount of potential, then you've got to have less potential energy
Why
here.
is the velocity equal to 0 up here then? Weren't we taught it's
Wait.
It's still
Right?
After no.
That's the thing. That's
Wait.
yeah. But hold on a second.
Stop.
No,
That's
we're right.
vertical motion.
Hold on, friends. So yes, Henry, we were taught, and if so, here this is why I love this question, because this is a case that doesn't match what we've seen before, right? The reason it doesn't match, the one that we did yesterday when one note went out, right? It was a ramp that looked like this. Do you remember that?
Yeah.
And so here was A, here was the block, and then here it was at B, and then we were looking at another place over here, C. But if you just let this thing on this frictionless surface go down, it would go all the way back up here, wouldn't it? And what would its velocity be when it got all the way up to the same height? It would be 0. That is absolutely correct. So you understand that. That's great. Yay. But the motion that the car has when it's doing this is different. Because now it's airborne and it is just being pulled down by gravity. This is just projectile motion, just like we've done forever. Okay? You with me there? And so since we know with projectile motion that it's got velocity up here, if it's got velocity, it's got to have kinetic energy. And if it's got kinetic energy, then it has to have less potential energy. And if it has less potential energy, it's got to have a lower height. That was just a rephrasing of what you said, right? Okay, Elizabeth, and then we'll come over here. Go.
Would it be the same thing if there was a track along that driveway?
Say that again.
Is that just, it only does that because it's projectile motion? What if that line do look like?
So that's a good question. Now, we kind of talked about that yesterday, I think. If you were going to design your own roller coaster on Roller Coaster Tycoon, right? And so you started at the top and you brought it up to the same height. Oops, mine went a little too high. Let me erase that. Right up to the same height. What's going to happen to the car here? It's going to stop, isn't it? It's going to stop. So it wouldn't keep going. That'd be a really unexciting roller coaster ride, right? Does that kind of answer your question? So you have to have this be just a little bit less than the total energy so that it's got some velocity to carry it over the curve.
So if it was the exact same height, it would stop at the top,
Yep.
or it would stop like.
Yep.
Because it can't.
If it was exactly the same height, now if this went up like this, right, then it would just come back down. Yeah. And then it would come way back up here and it would stop. Okay, it'd be literally an out and back coaster. Right? Go out and come back, and there you go. Kind of an anticlimactic ride, but not going to judge. Some people enjoy it.
So that's why, like, have you ever been to Disney World or Disneyland?
I have not for a long time, but you can keep talking.
Well, so like on Expedition Everest,
Sure.
when they go, okay, you all know what I'm talking about, right? Have you ever been there? You know,
There are a couple people that are on there.
With the Yeti, yeah. So you go like up this mountain, and then just like the track just stops, right? And it's supposed to be like the Yeti ate it, and then you just sit there and you go back. Yeah. Right. So that's because
Sure.
it's taller than the initial.
Yeah.
Right.
For sure. Cool. That's exactly right.
It also stops.
Do we get to go on a field trip? Does it stop?
If you want to fund it, I would be totally aboard for that.
It's supposed to be
I
like
actually
you're on
would
a
not be
train.
opposed to doing it after. I mean,
It's
we'll
like
talk
you're on a
about
train.
that.
It stops you suddenly, and then you stop.
I have done that in the
Fall
past.
back.
Yeah, I'm not. Let's hold on to that for May.
But yeah.
Yeah.
I know.
All right. Are we okay? Yeah. What?
Okay.
I'm gonna listen while I'm moving. Keep talking.
Okay, so after it is airborne, it's referring to.
Hold on, ladies and gentlemen, my friends, can you be quiet? Because Harrison is talking to me. I'm just going to get something while I'm listening.
This is on behalf of.
Oh, you're speaking on behalf of the one
Okay.
who doesn't want to speak?
Yeah. He was trying to argue that the question says after it is airborne, so he took that to mean in the whole system or whatever. After it is airborne also refers to the end where it goes on the next part of the track, and in that it will reach the height A.
Okay, let me read the question carefully here.
So the max height.
Hold
after
on.
it is
Jip. After it is airborne, will the maximum height of the coaster? Okay. Point taken.
No, yeah.
No, I'm saying.
Yeah.
but I think it's implied that the after means immediately after it is airborne. But I understand what you're saying, and I'm not going to argue with you about it because I see what you're saying. I'm just saying that I don't know that that's exactly the intention of the question. And either way, we learned something, so that's a beautiful thing, right? Okay. Are we good? Issues or questions there?
This is like a test question.
This is a little more technical than a test question. I feel like this is a good fodder for conversation. Yeah. Okay. Other questions before we move on to the next thing? All right. So I'm going to show you this thing really quickly, and then we will do a demo with it in just a minute. One of my favorite demo equipment pieces that I own. Okay. Speaking of slides. Okay. Right? It's fun. So this is like the ultimate water slide setup. Okay. So there are 4 different tracks here. So I want you to take a look at these, and I'm going to have you sit there, and then we'll go over and look at it in just a minute. But I just want you to get a sense of what they are. So they're color-coded. The one that's closest to you goes like this. Can you guys see if I do this? It goes down and out. Number 2 is a straight shot down. Okay. Number 3, which I don't know what color it is. We'll do 1 is closest to you.
That's blue,
2. This
yellow,
is 3.
green.
Thank you. Goes down like this. So it goes out first and then down. And then number 4 comes out really far and then goes down really steeply. Okay? So we'll just call them 1, 2, 3, 4. I want you right now on your paper to make 2 predictions for me. Okay? Prediction number 1 is, I'm going to put marbles on all of them so we can see. We'll actually test it. Which marble will win? So 1 is the one closest to you guys. 4 is the one farthest from you, closer to me. Okay? So 1, 2, 3, and 4, which one will win? And then the other question is, which one will be going fastest at the end? 1, 2, 3, or 4. Okay? I'm going to set this down right over here, so if you need to come look at it, you're welcome to do that. And then make your predictions. Write them down. This is you and your brain. You don't need to talk to anybody else about this. Make your predictions.
This has been up here the whole time.
I love it.
Oh yeah, there's
Which one's going to... I'm going to stop him. Which one's going to win? Yeah. We could do that too. Maybe we'll do that next. That's kind of fun too. I've had this, had one like this for a long time. That's fun. But that would be an interesting, I love that. Give me a high 5. Thank you for that. Well, so these are really, really close to frictionless, and I'm going to put marbles on them. So we're going to assume there's no friction. All right, so make some predictions, friends. 1, 2, 3, or 4. Who's going to win? And who is going to move fastest? No, I want you to make a guess. Prediction.